Children with autism often struggle with understanding emotions, which makes communication challenging. Now, there are many existing technologies out there that aim to help with emotion recognition, but most of them actually just focus on facial expressions rather than emotions in speech. But research indicates that recognizing emotions in speech is equally crucial for effective communication. So this gap in technology motivated me to create a system that can help children with autism identify emotions through spoken words. But before I get into the details of how I created the system, let us put ourselves in the shoes of a teacher or even a therapist. So, in order to effectively teach children with autism how to identify emotions in human speech, we need two things. First is appropriate materials, so sentences that contain unambiguous and clear emotions that the children can learn from. And then second is the ability to clearly and distinctly speak and express these sentences with their labeled emotions. However, there is a shortage of these therapists and specialized teachers trained to help these children recognize emotions in speech. And also, a study has shown that children with autism can actually learn more efficiently when interacting with a computer rather than a human being. And so therefore, I hope to offer a low cost and accessible approach that can do the jobs of these teachers and specialists and reach an even wider range of audience. And so here's where my system EmoBot comes in. It's an AI-powered interactive system for children with autism to learn emotions in human speech. So the engineering goals for the system was to have an appropriate data set that contains a large amount of sentences with clear emotions and then to find a text-to-speech engine. So in creating my system, I faced two main challenges. The first was that there was no suitable text-to-speech engine that could clearly convey a wide range of emotions. So originally, I was going to use the 8 basic emotions. However, after testing various text-to-speech engines, I realized that none of them could effectively and clearly convey all of these emotions. And so because of this, I had to narrow my selection of emotions into the 4 emotions: joy, sadness, fear, and anger, because these were the ones that Murph AI, the text-to-speech system that I ultimately chose, could express these with some clarity. And then the second challenge that I faced was the lack of an appropriate data set that I could use for my system. Because I am teaching children with autism, I need a data set that contains sentences with very clear emotions. The data set that I ultimately chose, called the Go Emotions dataset, contained over 200,000 sentences labeled with over 27 emotions. And so obviously the Go Emotions dataset could not be directly used for my system because it can contain too many ambiguous and inconsistent sentences. So the first step that I took was to use Python to categorize the sentences based on the number of emotions assigned to each. So some sentences had 1 emotion, some had 0, some had 2, some had 3 or more. For my system, I only used the sentences with single emotions. And then I further filtered these sentences to leave only the 4 basic emotions that I need for my system. And so this left around 15,000 sentences. Now, although these 15,000 sentences, they are the single emotions, their emotion identification difficulty level varies. So the next important step that I took was to create a classification model that can automatically categorize these sentences based on their difficulty level. So what I mean by their emotion identification difficulty level is that, for example, the sentence, "I am very happy today." This should be very confidently and easily categorized and classified as the emotion joy by the classification model, while the sentence, "I saw a flower," that would be harder to get classified with the emotion joy. And so the determination of the different difficulty level is through looking at the prediction confidence value that the model produces. So the classification model is composed of 2 parts. First is feature representation through the Roberta model. And so this will produce a this will produce a vector that contains the numerical representations of the inputted sentences. And then I used that output and passed it into the second part, which is a fully connected neural network that generates a probability vector, and this represents the prediction confidence. And so to evaluate the model's performance and to train it, I use the hold-off validation method. I split 80% of the data for training, 10% for validation, and then 10% for testing. So the classification model works by assigning a prediction confidence to each of the sentences. So it's basically a score indicating how confident the model is at labeling a sentence with a specific emotion. So going back to the previous example, I am very happy today. This should receive a prediction confidence around 0.9 because it's really easily to get classified with the emotion joy. And then to evaluate how confident and how accurate these predictions were, I calculated the precision. And looking at the results down here, we see that as the prediction confidence increased, the precision also increased. And so given this trend, I selected sentences with a prediction confidence of 0.9 or higher. And this is to ensure that the sentences that I selected are predicted with high confidence and high accuracy. And then step 3 was I inputted these sentences into the text-to-speech engine to produce verbal sentences. And then the last step was human-in-the-loop validation. So I had 2 steps in this. First was human labelers assessed the accuracy of the emotions for the randomly selected sentences from the classification model. And then they also validated whether the sentences spoken by the text-to-speech system can accurately represent the emotions in the sentences. And so down here, we see that the results show that the sentences selected by the classification model, they were indeed the most unambiguous, as the human labelers results matched the model's results at high accuracy. So most of these were 0.85 or above. And then the validation results also show that the MERF AI text-to-speech engine, it's not completely reliable in accurately and clearly conveying all of the 4 emotions, as we see that the emotion joy and sadness had a relatively low accuracy. And in conclusion, I created an automated classification model that can take any data set and it can automatically categorize its sentences based on their emotion identification difficulty level. And then I also integrated these sentences into the MERF AI text-to-speech engine to produce verbal sentences. So to the top right is the prototype of my system. So the users can sign in and then they will be brought into the homepage, which is the 100-day challenge. So I turn my system into this interactive aspect that the children can use. So they have 100 days, and the first 10 days are unlocked. Each day has 10 sentences that they can practice. And so this will keep them motivated to ensure that they know that they have a streak going on, and so they can practice every single day. And in the future, I will either create another classification model to select only the most clearly expressed spoken sentences from the text-to-speech engine, or I will use a newly developed text-to-speech engine to generate more expressive speech. And then I will also expand my system with additional features, such as storytelling mode, different difficulty levels, and then also a speech interaction feature where the children can speak back to the system and then get feedback. And yeah, that is my system.